Welcome to our second episode on the MikroTik Firewall series. Today, we're diving deep into one of the aspects that is critical for our network infrastructure, the protection of the router itself. So we're going to talk about the input chain and how we can protect the traffic that is coming to those devices, and in this way increase the reliability in our network. My name is Wilmer Almazan, and this is the Network Trip. Hello and welcome. In the previous episode, we learned about firewall basics, and we talked about different chains that we find in routeros. We talk about the input chain, traffic going to the router, the output chain, traffic leaving from the router and generated by the router, and also we talk about the forward chain, that is traffic that is passing through the router. So if I come here to IP services, so those are all the services that are open by default in routeros. So let's say that I'm only interested in some of those services. Probably I will be using only Winbox and SSH. So what I'm going to do is that I will disable all the remaining services. A good practice is to change those default port numbers as well. So I will keep the default value now, but a good practice is to set different values than the standard ports. But now what I'm going to do is that I will come here and I will accept connections to those services only. So remember, if we are going to get connected to the router, that is going to be input. So what I'm going to do is come in here, chain input, and the condition is that this is SSH traffic. So that means this is TCP port 22. So if the router is getting a packet that is going to TCP 22, we're going to accept that connection. And then I will say accept SSH. Another one, Winbox. So we're going to add a new one, and now we're going to say, okay, this is traffic going to the router, and this is going to the Winbox port. We're going to accept that. And I will add a comment, accept Winbox. So now we have those two. And the next one is going to be a deny for everything else. So I will go input, action, drop. So we're going to have a problem here, but just to understand how a stateful firewall works, I'm going to proceed with this rule, and then we're going to see what exactly is going to happen. And you will have a clear idea about what a stateful firewall is. So now I will apply the changes, and basically I will simply say drop everything else. So we can see that this is allowing SSH, this is allowing Winbox, and it's dropping everything else. So if I come here and I try to get connected to that device, so this is the IP in that device, 192.168.88.1, connect, you can see that I have access to that CCR 2004. And if I check the rules, and we can see here under the byte that we have the counter going up. If I go via SSH, so I will simply say here on my Windows, SSH, and then the IP of the router. So now you can see that I have access via SSH, and also that counter is increasing here. So everything looks good at this point, but let's see now what happened if I come to the terminal and I send a ping to 8.8.8.8. Enter. So we are getting a timeout, and here we have a problem. So now that means that the router is not getting the responses back. So you can see that the router is sending that ping message. So the echo request is leaving the router, that is output. But then the traffic is hitting Google's DNS server that is going to send the responses. But when those responses are coming, that is going to be input, because now the destination is going to be the IP in the router. And then that packet is going to come here. It's not going to match that entry. Then it's going to go to the next one. And then it's going to match the drop everything else rule. So that means that all the responses are being dropped. And that's why the router is not able to get that traffic. So if we check, we're getting timeout. So now we need to get the responses, but only for the conversations that were originated by the router. And then we can take advantage of that stateful functionality. So every time that this device is establishing a new conversation or is receiving a new packet from the client, it's going to add an entry to the connection tracking. So if I come here to connections, so you can see here that we have that conversation. So this is 10.9.9.254, so that's the IP on the one interface. So if I come to IP addresses, so you can see that that is the IP on my one interface. And here we have that conversation. So now the router knows that from that IP sent a message to 8.8.8, and then it's going to expect the reply from that IP going to that IP. Now we can tell the firewall that if it's receiving packets that belong a connection that is already established, then we're going to accept those responses. So let's see how this works. So now we'll simply come back to filter rules, and I need a new entry. So I will add a new entry. This is going to be on the input. And then if I go all the way down here under the general tab, I'm going to find the field, connection state. And then you can see here that we have established, we have related. So we're going to enable those two. So related is basically packets that are related somehow with the previous established connection. Like for example, if we are getting an error via ICMP or something similar, that's going to be detected as a related connection. So now basically we're telling if you are getting packets going to the router and they belong to a conversation that is already with an entry on the connection tracking firewall, you can accept that traffic, because it means that this traffic is a response. It's not traffic originated on internet. And then I will simply add a comment, accept established and related connections. And now the order is important. So if I go and I check, you can see that still is getting a timeout. And that is because the rules are matched in sequence. So that means that the first match is going to stop the processing of those rules. And then the response is coming to this rule 0, 1, 2 that is going to match, then it's going to stop at that point. So if we need to have this rule working, we have to put this on top of the drop everything else. Now you can see that the counter is showing some numbers. And if I go back to the terminal, that router is getting the responses back. But if I come to my computer and I send a ping to the IP on the router, that is not going to work. Why? Because the firewall is blocking. Now my laptop is trying to open a new connection. There is no rule here allowing ICMP, and basically that device is going to drop that packet. So how can we allow the echo request messages from the LAN but still block that from the outside? So we can add another rule on top of the drop everything else, basically saying, okay, if this ping is coming from my trusted interfaces, so in this case the LAN interface, I will allow the echo request message, but I won't allow anything else. So I will simply add a new entry. And the chain, again, is going to be input. The protocol is going to be ICMP. But now we're going to have more conditions. So the condition is that the traffic must come from a trusted interface. So in this case, it's going to be Ether 9. So we have Ether 9. But we have some additional condition, like for example, this must be an echo request. So I will come here to advanced, and then we'll go down. And then you can see here that we have some ICMP options. And we have the echo reply, we have the echo request. So I'm going to select that one because the client is going to send an echo request message. And then I'm going to say this is going to be accepted. And then I will add a comment here from LAN. And again, I will move this on top of the previous one. And now if I come back to the client and I send a ping, you can see that this device is able to talk to that router. So now we are allowing SSH and Winbox from everywhere. We are allowing established connection, that means responses to traffic that the router has originated. Then we are allowing ICMP request messages from the LAN interface, and then we are dropping everything else. So no IP service available. Additionally to SSH, Winbox, and the echo request for the LAN interface only. In some cases, you will be using your router as a DNS server. For example, if I have here under IP DNS, this option allow remote request enable, that means that this device is going to be able to accept DNS queries from the clients. So now I will enable that, and I will come here to my computer. I'm going to go to my Ethernet interface. And for the DNS server, I'm going to set 192.168.1. So basically that means that all the DNS requests that my laptop is going to send will be sent to the MikroTik device. So if I come back to my Windows system here, and I will flush the DNS entries, ipconfig flush DNS, and I send a ping to google.com, you can see that is not going to work. Why? The reason is pretty simple. This device is sending a DNS query to the DNS server, that is the MikroTik device, but we don't have any rules here allowing DNS queries. So you see, this is going to come to the rule, it's not going to match that, it's not going to meet the conditions here, the same thing for 2 and 3, and basically the drop at the end is going to match the traffic. So it means that we need to allow DNS queries, but not for everyone, just for the LAN interface. So we're going to do something similar to this rule. So now I will come back, I will go here to input, and I will say, okay, we're getting a DNS request coming on the interface Ether9. I'm going to accept that. Accept DNS using UDP. And sometimes that DNS can be using TCP as well, so I'm going to accept TCP. So we have a packet that is larger than 512 bytes. Also, it's going to be using TCP. So I will add those two, and I will put those on top of the drop everything else. And now if I go back to my laptop and I send a ping to google.com, you can see that that is working. And now I can basically start sending different DNS lookups. So this is basically sending DNS requests. You can see that this is able to get that information from the router. And that is because I have a DNS server enabled, and also I have these rules here that are allowing that traffic from the LAN interface. And basically this is the idea. If you want to protect your router, you're going to start adding rules to the input. And this is only going to allow the ports and services that you have specified here. Additionally, we can be more restrictive for some of those services. For example, instead of allowing the connection via SSH to everyone, we can add an address list. We can say, okay, we're going to allow SSH, Winbox, and some specific services, but only to trusted IPs. And then I can simply come here to address list that is still under IP Firewall. And I will create a list that is going to be called trusted IPs. I will add the IP on my laptop. So I will come here, IP config. So you can see that the IP that has my Ethernet interface has now is 254. So I will add that IP to trusted IPs. So here you can add a single IP, you can add the full network, or you can add a range, for example. something like that. But in this case, I will have just a single IP. Also, you can have multiple entries. For example, I can add another IP. Let's say something like 200. So you can have multiple entries, and all those entries belong to the same address list. And now if I come back to those rules, additionally to the protocol and port number, I can add additionally conditions to them. So I will come here and I will say, okay, I will accept that, but only if that is coming from trusted IPs. So I will select this condition. So if the traffic is going to a router from trusted IPs going to TCP/22, I will allow that. Same thing for Winbox. So I will come here, source address list, and then I will add trusted IPs, accept. So that means that now, if I try to go via SSH or Winbox from an IP that don't belong to that trusted list, the firewall is gonna block the access to the router. So I will go here to Winbox. Now my IP is in the trusted list, so you can see that I have access to it. But if I change the IP, so I'm gonna change the IP on my laptop. So I have set the IP 88.100. Still, the device will have access to internet. So you can see here, I will ping google.com. No problem, everything is gonna work. I'm able to ping the router, because remember that there is an entry in the router that is allowing ICMP from the LAN. But if I come and I try to open a new Winbox connection, that is not going to work. You can see this is not establishing the connection. Or if I try to go via SSH, that is not going to work. And the reason is that the IP 192.168.88.100 doesn't belong to the trusted IP, to the trusted IPs list. And basically now we have protection over, and now we are protecting the router. So the idea is that you will allow specific services and then you will drop everything else. And basically by doing that, we have applied the first strategy that we have discussed before. So we are allowing specific traffic and dropping everything else. And now we have a router that is going to be protected. Now it comes the question. So what happens if you tomorrow will be traveling to a different city or maybe to a different country, and the IP that you are going to have in that place is unknown at this point? So there is no way that you can add that IP to the trusted list, because you don't know what IP are you going to have in Germany or the Philippines or Japan or Mexico. So how can we still gain access to the router from a different city, from an unknown IP, without sacrificing the quality of our security rules? That's something that we're going to discover in the next video on this series on MikroTik Firewall. We're going to talk about port knocking and port scanning detection. So those two elements will play together to allow you securely access your device from a different city.